In this example given by f of x is x plus square root of 1 minus x minus 3 quantity squared. We want to compute the integral between 2 and 4. Sometimes there are some easy ways to compute integrals like this one. In this case, we don't need to use calculus to find this integral. We just have to be careful and see what we can get. So we can split this integral into 2 halves and see what we can do. But before that, we can see that this one is some circle centered at 3 and have a radius 1. So if we graph this one here, this second part, so this is the circle centered at 3 and have a radius 1. So that means it's this one here. So, and we know that the area, so we can split this integral, let's call it I. So we can split this integral in the following manner. So between 2 and 4 x dx plus 2 and 4 square root of 1 minus x minus 3 squared dx. Okay, this integral, since its center is 3, this is 2, this is 4, so we are computing this area here, and we know here this area because the area of a circle is given by pi r squared. Okay, and in our case r is just 1. That means we are looking for half the area here, and the area is pi, but we are looking for half of it. That means it's pi over 2. So we can deduce that this is pi over 2. For this one here, okay, there are many ways to compute this one. Okay, so we have our function is x, okay, but we are willing to compute it between 2 and 4. So here we can use any rules to compute this area, okay? And the area here, when x is 2, we have 2. When x is 4, we have 4. The area is just 6. Okay, we can compute it in any manner we want. Okay, and therefore we have the area as 6 plus pi over 2 without doing any calculus or any change of variable. Sometimes it's helpful to do this. And also I had to split this integral because I know this is convergent. It does exist, and this one does exist. Okay, that's why I had to split it, because the bounds are finite and the function is continuous, so the integral always exists. Okay, sometimes it's good to see like this one here. You see it without doing calculus. If we want to do calculus, we have to do some change of variable. Like this one here, we have to do x minus 3. When I compute this one between 2 and 4, square root of 1 minus x squared dx, first we need to change this one to some u. Okay, so therefore u is x minus 3. So when x is 2, u is minus 1. When x is 4, u is 1. Okay, and we have the square root 1 minus u squared. Du is just dx. Dx is just du. And now what we can do is we can do another change of variable. We can use u is sine theta. Okay, and here we can see that when u is minus 1, sine theta has to be between minus pi over 2 and pi over 2. Okay, so this is between minus pi over 2 and pi over 2, square root of 1 minus sine squared of theta, and du is cosine theta, d theta, and we get into the this value of computing the cosine theta in absolute value times cosine theta d theta between minus pi over 2 and pi over 2. And we have, since the cosine is positive between minus pi over 2 and pi over 2, we have to compute minus pi over 2 cosine squared of theta, d theta. And we have to linearize this one. So that means we have to do the cosine squared of theta is 1 plus cosine theta over 2. And we plug it here and we compute. Okay? We could have used many different ways, but you see, sometimes it's good to see the function that you have. Maybe it's 0, maybe it's symmetric, maybe it's even, maybe it's odd, and you simplify. Like in our case, we did it very quickly based on our assumption and our knowledge of the areas. Thank you.